Hello, this is Bryant Myers. I am a former college physics professor and best-selling author. And in this video, we are going to definitively debunk flat Earth with one of my favorite experiments that's actually happening tomorrow. And it's the Equinox sun experiment. It's a very simple experiment that anyone can do anywhere in the world to prove that we are living on a spinning sphere tilted on its axis orbiting the sun, just as the heliocentric model says. But before I get into the experiment, let me just explain a little bit about the equinox, which most of you are familiar. And there's a precise moment each September, which is usually around the 22nd or 23rd, when the sun is directly above the equator. And this marks pretty much the beginning of autumn. And this year, in 2021, it's going to be tomorrow, the 22nd, at 3:20 p.m. Eastern Standard Time. So at that time, the sun will be directly above the equator. Now, equinox, the word itself means equal night, if you break it down to equal and nox. And along with the solstices, the equinox marks the changing of the seasons. In this case, the change of seasons into the fall. And the days will get progressively shorter and the nights longer. So the change of seasons is caused by the tilt on the Earth's axis, as this illustration shows. So now, here's the experiment. So every vernal and autumnal equinox, the sun rises and sets exactly due east and west respectively, no matter where you are on Earth. And this is due to the very spherical shape of the Earth and the Earth's tilt. So at the equinoxes, the tilt is sideways with respect to the sun, so that's why we all are seeing the sunrise and sunset along the same longitude at the same time. So the rest of the year, the sun will rise or set a bit to the north or south due to the Earth's tilt towards or away from the sun. So here's a good way to test this out. You can actually take a video, again, along a street that runs due east and west. You can see the sun rise eastward in the morning along that east-west street, and you can see it set due west at night. And again, like I said, this only works with a spherical globe and the heliocentric model, as we pretty much have known since the time of Copernicus and Kepler and Newton. So that's a very definitive test. And now I want to show you why this does not work on a flat Earth. It absolutely does not work. This is a huge flat Earth fail. And look at this image here. So the flat Earth model has the Earth as a flat disk, with the magical little sun orbits, the sun and moon orbiting 3,000 miles supposedly above the Earth disk. Notice here that the sun is not going to rise and set due east and west. And I want to show you this really good demonstration done by Walter Bislin showing just how impossible the equinox sun is on a flat Earth. Okay, so now we're going to run the demonstration. So you can see here, again, this is the flat Earth with its dome, and the sun is up here. Okay, again, the sun orbits supposedly 3,000 miles above the flat Earth. And this right here is the known day and night patterns that have to happen because we can all observe them. So flat earthers can't deny this because we all can observe the sun rising and setting due east and west in all these locations. So for this to happen on a flat Earth, what's going to need to happen is ridiculous refraction angles. And what I love about this animation is it shows you very visually just how much, look at this here, look at how much refraction you have to get, especially on the edges. Okay, so these type of refraction angles, and you can see now here the day and night along different longitudes, it's just absolutely absurd. I mean, if the Earth was a sun 3,000 miles above, it would just kind of be this little, well, first of all, it would illuminate the entire disk. But the flat earthers say it's like a spotlight shining straight down. But how does the spotlight know to stop exactly along this line? And how can the spotlight curve at these ridiculous angles to bring light over here versus at the same intensity as light over here? I mean, it just doesn't make any sense. Now, the atmospheric refraction index, even at sunset, is a maximum of 0.58 degrees. So we just cannot get this amount of refraction with the atmosphere that we live in. And again, there's no model that, even if we could, there's no model that explains why there would be this type of refraction on an equinox sun. Not to mention, this actually applies to all the different light patterns throughout the year on the flat Earth. I don't want to, maybe we'll do that in another video to show how something as simple as day and night is just not possible on a flat Earth. Because if this Earth was orbiting above, you would see it on the other side of the planet. There would be no night. You would always see this, even if it was a spotlight. And I find it really humorous that in one of the Flat Earth's main documentaries, I think it's called Level with Eric DeBay. In one of their more popular documentaries right now, they're actually demonstrating this spotlight sun. And in the demonstration on the side of the Earth that should be dark, you can see the spotlight. I mean, they literally contradict themselves. It's just so absurd. So I encourage every one of you to go out to an east-west street tomorrow, watch the sun rise in the east and set in the west. And if you can post a video on YouTube from around the world, we'll see that this is true. Anywhere in the world, we're going to see the sun rises and sets due east and west respectively, everywhere on Earth tomorrow at a given longitude. So thank you so much for watching. I hope you enjoyed this video, and I hope you have a great fall equinox tomorrow. All right, take care. Bye-bye.